Hello Year 10. Today we are moving on to a new unit, which is electromagnetism. It's a relatively short unit and it builds on lots of information that we've learnt previously, as well as information that you've probably been acquiring since a very young age and is embedded in from year 1 upwards. So we're going to look at magnetic fields today, and in particular we're going to look at the following outcomes. We're going to describe the force rule for two magnetic poles near each other, explain the pattern of magnetic fields around a bar magnet, and lastly, explain the meaning of magnetism. For those of you who are aiming for a 6 or above, whether it's on triple or trilogy, you do need to know why steel, not iron, is used to make permanent magnets. So this is the rag sheet for today, this unit. And you can, as always, use the Caboodle online textbook to look up material. And I've also attached a bite-size link at the bottom that you may find useful. So, some quick revision. If we can put these in the margin of our books, 1 to 5, just quickly pause the slide now and do the quiz for me. So, state the name given to a system where there is no net gain or loss of energy. We call that a closed system. And then number 2, an object was lifted and placed at rest on a shelf. What store of energy would it be transferred from the object to now at rest? It's kinetic energy. State the unit of energy is measured in, and that is joules, J, capital J. And give the equation used to calculate work done. That's work done equals force times distance. And lastly, the distance. The unit of distance is meters. So here we have 4 pairs of magnets, and each pair has a different set of poles. We know that each magnet has a north and a south pole, and there are some simple rules. So which of these pairs attract and which of these pairs repel? Think about why. It should be just a simple statement. Right, let's see what you got. So opposite poles will attract. So B and C are attracted to each other, whereas like poles or same poles, A and D, will repel each other. Okay, and that means push away. So here we have some magnetic materials. Now, you've probably seen this done in class, and you've probably messed around with iron filings yourself in a lesson. And what we see here is a bar magnet, and what's happened is we've shaken iron filings around the bar magnet, and that shows me my magnetic fields. What the bar magnet doesn't do is show me the direction of the lines of force. You can get the indication of the lines of force, but from the top picture A, you can't see which one is the north and which one is the south pole. We would need to add something called a plotting compass to that to give us the north and the south pole. Now you can see the plotting compass at the bottom diagram here, okay, and that is showing me that the line of magnetic flux is coming from the north to the south, okay? And the region around the magnet is called the magnetic field. The magnetic material in space will be experiencing the force of the magnet. And the lines are called magnetic field lines. The closer the poles, the stronger the force. So the direction of the line, the force is always from north to south. And we can test that again, as I described, using a plotting compass. And that will always point towards the south. So the Earth does have its own natural magnetic field. And therefore, because the Earth has its own magnetic field, it's not actually, that's why the Earth is slightly tilted, because it's actually slightly skewed to one direction. So the geographical North Pole and the magnetic North Pole are 2 different places. And scientists have plotted the magnetic field accurately, and we basically have used plotting compasses and magnets to do this. So the fact that the Earth is turning very, very slowly, and inside our core of our Earth we have a core of a core of iron and nickel. Those materials are magnetic and they are magnetized. There is evidence the Earth's magnetic field changes direction over time, about every 10,000 years or so. So it's not happening like every other evening or every 28 days like the moon cycle. It is over 10,000 years. So not within our lifetime, guys. So nothing to worry about there. And these changes impact animals that use magnetic fields to navigate. If we think about birds migrating, or bats, or some of the other animals that migrate across the world in order to find a mate or to experience warmer weather at the equator, they will use the Earth's magnetic fields as a navigation system. Right, so we can talk a little bit about permanent magnets. Now, permanent magnets produce their own magnetic fields, and they can attract or repel other magnets. We sometimes think of this what we call a horseshoe magnet because it does look like a horseshoe. Never used as horseshoes because they'd be rubbish because they're quite soft. However, the shape itself implies horseshoe magnet. These little rod ones are called bar magnets. Okay, and these are button magnets. Okay, again, don't use them as buttons, they're rubbish. So, induced and temporary magnetism. So what we've got here is, you can all read this, but essentially we have unmagnetized iron, and these have magnetic domains within them. All iron has that, all steel, iron, nickel and cobalt has this. What we can do then is, by using a permanent magnet, we can induce magnetism. So the permanent magnet at this end basically pulls all those domains so they follow the same direction, creating a magnet. Now those domains are temporary, okay, and they are temporary because if you heat that material up or you bang it, the domains become all jumbled again and start pointing in different directions and no longer hold their magnetic properties. However, it can be simply re-induced using a permanent magnet. So, induced magnets. So, become a magnet when placed in a magnetic field. They lose their magnetism when removed from the magnetic field. They only cause attraction. They don't cause repulsion. And they're made of magnetic materials: iron, nickel, cobalt and steel. I always remember that as sink. Okay, my kitchen sink, obviously that poorly spelt with a C, is magnetic. We often get asked in exams, you often get pictures of magnets where they're asking you what's attracted and what's repelled. But actually, for the higher people, you're just thinking, well, I know loads about magnets. But what they actually want you to know is that induced magnets, if you wanted to test if something was a permanent magnet or an induced magnet, it only attracts to something else. So if, for instance, we were looking at my nail here that was an induced magnet, if I then turned it around so that my north end was pushing against the north end of my magnet here, so this north end, and put it on this end, you wouldn't get the repulsion. Okay, you'd just get attraction. Okay. But it would just flip around, and that's really important. Okay, the reason we don't heat magnets up and we ask you to be careful with bar magnets is because they lose their magnetic field and their regions of magnetism become disaligned through this process. And so what I would like you to do, and this is up to you whether or not you do it, I will show you the mark scheme in a minute. I'd like you to create a thinking map like the one below and plan the perfect answer to this question. So, I would like you to compare induced magnets to permanent magnets, and I want you to think about them in two regions. What characteristics do induced magnets have? What characteristics do permanent magnets have? And then overlap their similarities. So to the sides of each of your mind map, your thinking map, I would like you to have your differences, and in the middle, your similarities. So the keywords that we'd like you to use is magnetic field, and here is the answer. Okay, give yourself a mark. If not, if you're thinking, well, I have no idea what she's asking me to do, these are the things that you need to make sure that you know, so copy these down. Now there is a SAM learning task that goes with this activity, so can we please make sure that that's done? And I always wait till the end of the SAM learning task before I upload it on to show my homework. As always, some of you are doing awesome work. Some of you need to work a little bit harder. However, every little helps in terms of trying to get this work learnt. So think about it, pause this, make sure you got this down. Even now, retrospectively build your mind map. Okay then, see you tomorrow guys, bye.